In this video, we are going to go over how to simplify radicals or square roots by using what I like to call the alternative method. This is not the method that I prefer to use, but it is a method that is often taught, so I'd like to explain it just so you understand why it works and how to use it. In future videos, I'm going to use my preferred method, which is looking for the largest perfect square that goes into each radical. I already showed that in a previous video. You'll want to check that one out. I prefer that method because it will save you lots of time, especially when the going gets tougher in later math courses. All right, let's check this out. So what we use here with the factor tree method is you factor everything down to its prime numbers. And if you forget how to do that, watch videos in my pre-algebra or even middle school 6th grade courses where I go over how to do a factorization, a prime factorization. So I reduce down 8 to 2 and 4. 2 is prime. A lot of people will then circle that number to show that it's prime, but 4 still has 2 and 2 that goes into it. So now everything's prime. What we do now is we notice that we have 1, 2, 3 factors of 2. Any place where we have 2 factors of something, they pair up and they come outside of the radical. Let me show you why that is. Essentially, we just rewrote this as 2 times 2 times 2. So what you now have is you have the square root of 2 squared times 2. There's that factor pair. So teachers will often say anything that goes in a pair goes out. I've even heard that if something pairs up, it goes out on a date, which is not math, but it's a cute way of remembering it. So the reason why is the square root of 2 squared. That's what's going on there. You're basically saying, what number times itself gives me 2 squared? 2, right? 2 times itself gives me 2 times 2. So that's why the 2 comes out, and you're left with a 2 here that is not paired up. So it's 2 times the square root of 2. You can look at that as the square root of 2 squared times the square root of 2. That's the square root of 4, which is 2. I think that's much lengthier, but it's a way that a lot of people are comfortable. All right, let's use that same method a couple more times just so you see it in use. So 12 can get factored down into, let's do 3 and 4. That's a prime factor. And then 4 into 2 and 2. Circle your primes. Notice that 3 does not get paired with anything, but the 2's do. So 1, 2 will go outside because there's one pair, so there's 1, 2 squared. And so they're now done, and a 3 remains on the inside, and you get 2 root 3. Again, there's one pair of 2's, so there's 1, 2 that goes to the outside for the reason I explained over there. Not a big fan of the factor tree method, but you can use it for now if you like. I'd encourage you to get that preferred method down, though, pretty strongly. Okay, 7, D2. 72, we've got 8 and 9. There's other factors we could use, but we'll break it down there. Each of those get broken down more. 2 and 4 for 8, 2 is prime, 2 and 2 for 4. 9 gets broken down into 3 and 3, each of which are prime. So we got a whole bunch of pairs. We have 2's, so they're going to go to the outside, and we have a pair of 3's. They're all being multiplied on the inside, they'll be multiplied on the outside, so you have 2 times 3, with a 2 remaining inside the square root, the radical. 2 times 3 is 6, you get 6 root 2. All right, so again, this has been a quick video on how to use factor trees to simplify square roots. Again, check out that preferred method. It's preferred for a reason.